All right, guys, we're going to be talking about angles, their names, different types, different types of relationships, and then we're going to work through some different problems here in a minute. All right? So this says angles and other word problems, or other problems run through. So here's a lot of different types of angles that we need to know. We need to know what the definition is. We need to know what they look like. I'm just going to kind of go over these. You can look them up other places, but complementary angles are two angles. Let's make that a bit thinner. They're two angles, so it has to be two. Two angles that add up to 90 degrees. So I'm going to go through and see if I can find some complementary angles. On the left side here, we're looking for complementary angles. It has to be two angles. They have to add up to 90 degrees. And we're talking about the angles that have numbers in them. So like on this picture, ignore that one. We're not talking about the blank one. So we're only talking about the angles that have a value associated. So here, do we have two angles that add up to 90 degrees? I see a 60 and a 30, and that's a big yes. Those are complementary angles. Nailed it. 50 and 20, that adds up to 70. That is not complementary. 150 plus 30, that's 180, not complementary. Those are both 100 degrees, not complementary. This one might get a few people, but that's a 90 and a 90. What is 90 plus 90? Ooh, that is not complementary. So the only yes was that very first section. It's the only ones that added up to 90 degrees. The rest are big no's. All right. Supplementary angles. Those are two angles that add up, that's important phrasing there, to 180 degrees. Don't say two angles that are 180 degrees. That to me means two 180 degree angles. No. They have to be two angles that add up to 180 degrees. Well, if these are complementary, they can't be supplementary. 50 plus 20, nope. 150 plus 30, yep. Those are two angles that add up to 180. 100 plus 100, nope, that's 200. What about 90 plus 90? What did we say a second ago? Yes, those do add up to 180 degrees. So these are two pretty basic definitions here. One way you can remember which one's which, because people do mix these up pretty often. I don't know if this helps people, but I look at the word complementary. If you focus on just the first part, if you just drop a line down, you actually make the number 90. 90 degrees, complementary. And here, you can finish the S, and it looks like 180, or it looks like the number 8 for like 180. I don't know if that kind of thing helps you, but that's the kind of thing that I use to help me memorize. Now, adjacent has a different definition. Adjacent is side by side. They are side by side, and to be more specific, they have to share a ray. So they have to have a common ray. So again, we're just talking about the numbered angles. So the 60 and the 30, they're not adjacent. The answer is no. They don't share a ray. They share a vertex. Don't they both start at the same spot here? Yes, but they're not adjacent. They do not share a ray. How about these two? Are these side by side? Do they share a ray? That answer is yes. They both have this vertex. They both use this ray right here. So 50 degrees uses it, 20 degrees uses it. Yes, yes, yes. That is an example of adjacent angles. So adjacent means side by side shares a ray. How about these guys? Side by side, do they both use this? If you were to draw the 30-degree angle, does it use this ray? Yes. If you draw the 150, does it use the same ray? Yes. So they both use this ray. So again, 150 and 30, yes, they're going to be adjacent. How about 100 and 100? Look at those. They share a vertex, and we're going to talk about this in a little bit, but the top 100, it uses these two, and the bottom 100 uses those two rays. So those are not the same rays at all. They have zero shared rays. They have a shared vertex, but no shared rays. And then same thing here. They have a shared vertex, but no shared rays. So the first three situations, not too complicated for most people. Side by side share a ray. Maybe that gets a little confusing sometimes. But linear pair and vertical, those can be a little bit harder to understand for a lot of people. So linear pair, what is a linear pair? They are They're actually a combination of two of the definitions we just said. They are supplementary, adjacent, supplementary and adjacent. That's their definition. They must be both things. They must be supplementary and adjacent. Another way I could say it is they must be two angles that form a line. And that's where the word linear pair comes from. Pair is two, linear meaning line. A linear pair is two angles that form a line. You can think about it either way. So what we're looking for is two angles that form a line, meaning, like if this is angle 1 and 2, angle 1 and angle 2, if you put that together, if you put that all together, do you have all 180 degrees of the line? If you do, you have a linear pair. How many degrees are in a line? I just said it a second ago, but there are 180 degrees in a line. So they have to be supplementary. And in order to form a line, they have to be side by side. They have to share a ray. So they're going to be supplementary and adjacent. That's a linear pair. The only linear pair in our group here is this 150 and 30. That's the only one. Where'd our orange go? There we go. This is the only one. The other ones are all no's. None of those are linear pairs. So notice that the last one here was supplementary, but not a linear pair. And this group here was adjacent, like 50 and 20, that was adjacent, right? It was adjacent. We said yes, but again, not a linear pair. So some of the questions I would ask you is like sometimes, always, or never, are linear pairs supplementary? Well, linear pairs have to be supplementary. It's actually part of the definition I gave you. Yes, that's always. But if I turn the tables, do supplementary angles have to be linear pairs? And that's where it gets a little icky. But right here, are those angles supplementary? Well, we said yes, they add up to 180. But would you say they're a linear pair? That answer is no. And some of you might be like, well, Mr. Bennett, I can move them. I can move them, Mr. Bennett. I know you can move them. I know you can move them. But location matters. Right now, as they sit, that is not a linear pair. So like I drew an example, that's a linear pair. Maybe this angle is like 80 degrees. Maybe this angle is 180 or 100 degrees. So yes, those are supplementary angles for sure. That's a linear pair for sure. But if I take those angles, it's not going to like me. Sorry, I guess it doesn't make angles. So if I take those angles, and like if I have like this angle is 100 degrees, and then over here I have an angle that's 80 degrees, this is supplementary, but not linear pair. And I'm going to write just LP for linear pair. Those are supplementary, but not a linear pair. These are a linear pair and supplementary. So a lot of people confuse linear pair with supplementary. They have to be adjacent. They have to form a line to be a linear pair. They do not have to be adjacent to be supplementary. So those are different things. We got to get that down. Sometimes, always, or never, adjacent angles are linear pairs. Well, here are some adjacent angles that are also a linear pair. So it can happen, right? Can I have adjacent angles be a linear pair? Yes, I can. Can I have adjacent angles that are not a linear pair? Look at this one. Those are not a linear pair, but they're adjacent. So that would be sometimes. Sometimes adjacent angles are linear pairs. But if we flip the order of that, if I said linear pairs are adjacent, that's got to be always. That's part of their definition. They have to be side by side. They have to form a line. So linear pairs have to be adjacent. Yes. All right, and then maybe the most confusing of the group, vertical angles. So what is a vertical angle? What color are we going to use? Let's go green. Vertical angles are, there's a few ways to put it, but I'm going to say that vertical angles are angles formed by opposite rays. That might not make much sense to you. You have to know what opposite rays are. But they're the angles formed by opposite rays. So let me show you what I mean. If I have an angle here, right? I'll call that angle 1. where would its opposite rays be? Something like this and this. Opposite rays go the exact opposite direction. So angle 1 and 2 are using opposite rays right now, and this would be green and green. Angles 1 and 2 they use opposite rays. Their rays go exactly opposite directions. So those are vertical angles. They face exactly opposite directions. As a matter of fact, when you make vertical angles, you actually always make two pairs at the same time. These two angles, 3 and 4, would also be vertical. Angle 3 has these two rays as its sides. Angle 4 has these two rays as its sides. Are those opposite rays? Do they go exactly opposite directions? Yes, they do. Now, don't get that confused. So if I have an angle, we'll call it angle 1. Let's say that we extend one side, but then the other side does something like this. Are those opposite rays? Well, this is an opposite ray. Yes, that's an extension of this line. So that's an opposite ray. But is the other one an opposite ray? If you were to keep going, is that? No. Opposite rays must make a straight line. So I might want to add that up here just so we know. Opposite rays must make a straight line. Must form a line. All right. So let's go through, see if we understand. Vertical angles, do those use opposite rays? No. If I were to keep going with the 30, this is the vertical spot. Those are vertical, and that's not in the picture. That's a no. That's a no. How about 50 and 20? Let's look. Keep drawing. Nope. Here's the vertical spot to 50. That's a no. Okay, we keep the ball rolling. Do we see a set that is vertical? It's not the next one. That's a no. How about the 100s? Keep going. Ooh. Keep going. Ooh. Yes. And then the 90s fit the bill as well. 90s are the same idea. Those are also vertical angles. So the last two sets are yes. And one thing to note is that when you create vertical angles, what does it look like? Like the size of the angles, if the rays are exactly opposite directions, they're actually going to form congruent angles. So I'm going to make another note up here. Always congruent. They're always the same size. So here's some good questions. Sometimes, always, or never. Vertical angles are supplementary. Vertical angles are supplementary. Can that happen? Yes, those are vertical angles. Those are supplementary. Does it have to happen? No. These are vertical angles. Those are not supplementary. So sometimes, always, or never. Vertical angles are supplementary. Sometimes they are. They would have to be exactly 90, but they can be. How about complementary? Can vertical angles be complementary? Let's see here. Could I have angles that are vertical that are 45 degrees each? Could that happen? What's 45 plus 45? It's 90. That would be sometimes. They don't have to be 45, but they could be. All right, those are some words we need to know. We're going to go through real quick. Bisects. Bisect. Bi means two. Sect for sections. I think we've talked about this before, but it's two equal sections. So it's saying AB bisects angle CAD. That means it cuts in half angle CAD. And it's kind of cut off, but this is the letter D down here. All right. Find the measure of all the angles. Is it a right angle? Is CAD a right angle? So this is what we know. We know that AB is an angle bisector. And we know for sure that these two little angles have to be equal. Bisect means to cut in half. So the entire angle is cut in half by that bisector. So we know these two parts have to be equal. We know that 6x plus 3 has to equal 8x minus 7. Therefore, 2x must equal 10, x must equal 5. But that doesn't answer the question, is it a right angle? Let's test it out. So we know that x equals 5, so we plug it in. 6 times 5 plus 3, that is 33. And how about this? 8 times 5 minus 7, that's 33. And we knew they had to be equal, so we just checked our work. We know that we have the right answer because they had to be equal. Is it a right angle? The answer is no. Find the measure of all the angles. 33, 33. The whole thing is 66. There we go. Find the value of x in the measure of all angles. Well, these are vertical angles. How do I know? They have opposite rays. So what do I know about these two angles? We said vertical angles have to be congruent. I know that x squared minus 4x has to equal 5x plus 10. I'm not going to go into a deep lesson right now on this, but I will just remind you that vertical angles are equal. That how to solve a quadratic. I lost track a little bit. This is a quadratic equation. We're going to factor it. I'm going to go real quick through it though. X squared, one of the first jobs is we got to make one side 0. I want to keep x squared positive. So what I'm going to do is I'm going to subtract 5x from both sides, and I'm going to subtract 10 from both sides. And what I end up with is x squared minus 9x minus 10 equals 0. I'll go over this in a lot more detail another time, but this is just a quick reminder for those of you who remember how to do it. And this number 10 is so important. I need the factors of 10. This tells me they have to subtract. What are the factors of 10 that subtract to equal negative 9? And it's 1 and negative 10. So the factors are x plus 1 and x minus 10. All right. So x equals negative 1 and x equals 10. Well, we need to test them out. It's possible that they don't both work. So let's see. I'm going to plug in negative 1. Negative 1 squared minus 4 times negative 1. That would be 1 plus 4. That works. 5 times negative 1 plus 10. That would be negative 5 plus 10. That would be 5. That works. So those are the same. So that checks out. How about if we plug in 10? This would be 10 squared minus 4 times 10. That's 100 minus 40. Ooh, that's okay. An angle could be 60. 5 times 10 plus 10, that is also 60. So find the measure of all the angles. It could be 60. And if those are 60, then these have to be 120. Why? These are a line. How many degrees are on a line? 180. So it could be 60 and 120. The other option is the 5. So if that's 5, how big is this one? 180 minus 5 would be 175. So it's either 60 and 120 or 5 and 175. It's one of those sets. That's the measure of the angles. All right, we're going to save this for another video because it's kind of its own thing, but hopefully that was helpful.